Bread is one of the oldest foods known to humanity. Yet today, billions of loaves are produced every year with incredible speed, precision, and consistency. What looks simple on the outside, soft slices, golden crusts, and familiar aromas, is actually the result of a highly controlled and complex factory process. In this video series, we'll walk through the complete industrial bread-making process, step by step, from raw flour delivery to the final packaged loaf ready for store shelves. And it all begins with one essential ingredient: flour. 1. Flour arrival and quality control. Inside a modern bread factory, production starts long before dough is mixed. The journey begins at the loading bay, where massive tanker trucks arrive filled with flour. These trucks don't just dump their contents and leave. Every batch of flour undergoes strict quality control checks. As samples are taken and tested for moisture content, protein levels, color, and texture. Why does this matter? Because even slight variations in flour quality can affect dough elasticity, fermentation, and the final texture of the bread. Factories rely on laboratory technicians and automated testing systems to ensure consistency. Only flour that meets precise specifications is approved for production. Once cleared, the flour is pneumatically transferred through sealed pipes into large storage silos. These silos can hold several tons of flour, protected from moisture, pests, and contamination. At this stage, the factory already knows exactly how much bread can be produced from this batch. 2. Precise ingredient measurement. Bread may seem simple: flour, water, yeast, and salt. But in a factory, precision is everything. From the silos, flour is released into automated weighing systems. High-accuracy scales measure each ingredient down to the gram. Alongside flour, other ingredients are prepared: water, temperature-controlled yeast, either fresh or dry salt sugar, or sweeteners, fats, or oils, dough improvers, and enzymes. Depending on the recipe, each ingredient plays a specific role. Yeast controls fermentation. Salt strengthens gluten. Water activates proteins and starches. Even tiny miscalculations can change flavor, volume, or shelf life. Everything is programmed into the factory's control system, ensuring that every batch is identical. 3. Industrial dough mixing. Now comes the moment where bread truly begins to take shape. The measured ingredients are transferred into industrial dough mixers, machines powerful enough to handle hundreds of kilograms at once. As the mixer starts, the transformation begins. Flour absorbs water. Gluten proteins stretch and link together. The dough becomes elastic, smooth, and cohesive. Unlike home baking, where mixing takes minutes, industrial mixers work with exact timing and speed settings. Sensors monitor dough temperature and consistency in real time. If the dough gets too warm, gluten weakens. Too cold, and fermentation slows. Everything is carefully controlled. This stage determines whether the bread will be soft, chewy, airy, or dense. Once the dough reaches the perfect structure, it's ready for the next critical phase. 4. Dough resting and fermentation begins. Freshly mixed dough isn't ready to bake yet. It needs time to rest and ferment. The dough is transferred to large fermentation containers or resting conveyors. Here, yeast begins its work. Yeast feeds on sugars in the dough, producing carbon dioxide and alcohol. The gas gets trapped inside the gluten network, causing the dough to expand. This is what gives bread its light, airy texture. Temperature and humidity are tightly regulated. Too much heat speeds fermentation too fast. Too little slows it down. In industrial bakeries, fermentation is not left to chance. Timers, sensors, and climate-controlled rooms ensure perfect results every time. At this point, the dough is alive, expanding, and developing flavor. But it's still far from becoming a loaf. 5. Dividing and scaling the dough. After fermentation, the dough moves into dividing machines. These machines cut the large mass of dough into equal portions. Each piece is weighed automatically to ensure uniform size. This step is essential for consistency. Every loaf must bake evenly, fit packaging standards, and meet weight regulations. Once divided, the dough portions are gently rounded. This rounding process smooths the surface and prepares the dough for shaping. Even at this stage, care is taken to avoid damaging the gluten structure. Rough handling can release trapped gas and ruin texture. The factory process balances speed with delicacy, something only automation can achieve at scale. 6. Why this stage matters. Everything we've seen so far sets the foundation for the final product. Quality flour, precise measurements, controlled mixing, careful fermentation. If any of these steps fail, the final bread suffers. That's why modern bread factories rely on advanced technology, trained staff, and constant monitoring. The goal isn't just to make bread fast, it's to make it perfect every single time, and we're only getting started. Before we finish this journey, make sure you're subscribed to the channel and hit the like button. Videos like this take you inside processes most people never get to see, and if you stay until the end, you'll never look at bread the same way again. Now, let's complete the story, from the factory floor to your table. This final phase is all about precision, hygiene, speed, and preservation. 1. High-speed bread slicing. Once cooled, loaves are transferred to industrial slicing machines. These machines are designed to cut bread at incredible speeds, often slicing dozens of loaves per minute without crushing or tearing the soft interior. Blades are razor-sharp and carefully spaced. Slice thickness is programmable, allowing factories to switch instantly between thin sandwich slices and thicker cuts. The bread is gently guided into the slicer. Sensors ensure alignment. Any loaf that's too soft, too hard, or misshapen is automatically rejected. Consistency is key. Consumers expect every slice to be identical, and in large-scale production, automation makes that possible. Once sliced, the loaf moves immediately to packaging to prevent drying. 2. Automated packaging systems. Packaging happens fast, often within seconds of slicing. The bread enters automated bagging machines, where it's enclosed in food-grade plastic or specialty packaging materials. This packaging isn't just for convenience. It plays a crucial role in preserving freshness. Modern bread packaging is designed to control moisture loss, prevent contamination, extend shelf life, maintain softness. Airflow, sealing pressure, and bag tension are all carefully calibrated. Some factories also use modified atmosphere packaging, adjusting oxygen and carbon dioxide levels inside the bag to slow mold growth. Once sealed, each loaf is clipped or sealed with a branded tag displaying production date, expiration date, batch information. This ensures full traceability from factory to store. 3. Metal detection and final safety checks. Before leaving the production line, every packaged loaf passes through metal detectors. These machines identify even tiny metal fragments that could pose a safety risk. If anything unusual is detected, the product is automatically removed from the line. This step is mandatory in modern food production and reflects strict international safety standards. In addition to metal detection, factories may also use X-ray scanners, weight checks, seal integrity inspections. Food safety isn't optional. It's built into every step. Only bread that passes all checks moves forward. 4. Coding, labeling, and traceability. Next comes coding and labeling. High-speed printers mark each package with batch codes, production times, facility identifiers. Why is this important? Because traceability protects both consumers and manufacturers. If an issue ever arises, factories can quickly identify when the bread was made, which ingredients were used where it was distributed. This level of control allows fast recalls and ensures accountability. Behind every loaf is a digital trail. 5. Crate loading and palletizing. Once packaged and labeled, bread is grouped into crates. Robotic arms or automated loaders stack loaves carefully to avoid crushing. Crates are then arranged onto pallets in precise patterns designed for stability during transport. Pallets are wrapped, secured, and labeled for shipping. Everything is optimized for efficiency, space utilization, load balance, speed. At this stage, hundreds or even thousands of loaves are ready to leave the factory. But timing is critical. Bread is a fresh product, and freshness drives quality. 6. Distribution and logistics. From the factory, bread enters a carefully planned distribution network. Delivery schedules are optimized to ensure bread reaches stores as quickly as possible, often within hours of baking. Temperature-controlled trucks maintain ideal conditions during transport. Some bread goes to supermarkets, convenience stores, restaurants, schools, and hospitals. Others are delivered directly to distribution centers for regional delivery. Logistics software tracks every shipment in real time. The goal is simple: deliver fresh bread, fast, and consistently. 7. Shelf life and consumer experience. Once bread arrives at the store, the final stage begins: the consumer experience. Shelf placement, stock rotation, and expiration dates all influence freshness. Thanks to the factory process, texture remains soft, flavor stays balanced, crust retains structure. From flour quality to fermentation timing to packaging technology, every step contributes to what consumers experience at home. That soft sandwich in the morning, that toast at dinner, that familiar smell when a bag is opened, all of it traces back to this process. 8. Why this process matters. Industrial bread production is more than mass manufacturing. It's a balance of science, engineering, and tradition. Factories don't just make bread. They ensure food safety, consistent nutrition, accessibility for millions. Behind every loaf is a system designed to deliver quality at scale. What once took days by hand can now be done in hours, without losing reliability. That's the power of modern food production. 9. Final reflection. From raw flour delivered in silos, to precision mixing and fermentation, to baking, slicing, packaging, and delivery, bread travels an incredible journey before it reaches your table. It's easy to take it for granted, but now you know the full story. If you enjoyed this complete breakdown of how bread is made from flour to finish, like this video, subscribe to the channel and share it with someone who loves food science. More behind-the-scenes factory processes are coming soon, and you won't want to miss them. Thanks for watching, and next time you pick up a loaf of bread, you'll know exactly what went into it. If you're finding this process fascinating so far, support the channel by liking this video and staying subscribed. We're about to move into the most dramatic transformation of all, where dough finally becomes real bread. This is the stage where shape, volume, texture, and aroma are truly defined. 1. Dough shaping. Creating the final form. After rounding, dough portions travel along automated conveyor belts toward shaping machines. These machines gently stretch and fold the dough into its final form. Whether it's sandwich loaves, buns, rolls, or specialty shapes, each product follows a precise shaping path. Rollers flatten the dough. Guides fold it evenly. Pressure is carefully applied to remove large air pockets while preserving the internal gas structure. This balance is critical. Too much pressure, and the bread becomes dense. Too little, and the loaf may collapse during baking. Every motion is calculated. Every second is timed. By the end of this step, the dough finally looks like bread. Long loaves, smooth buns, or uniform rolls, ready for one last rise. 2. Pan loading and alignment. Once shaped, the dough pieces are automatically placed into baking pans or trays. Robotic arms or synchronized loaders align each piece with precision. Spacing is carefully controlled to allow proper expansion during proofing and baking. For pan bread, dough is placed seam-side down into greased molds. For free-form products, trays guide shape without restricting expansion. This stage may look simple, but it's essential for uniform results. Even spacing ensures even heat distribution later in the oven. Consistent placement ensures identical appearance across thousands of loaves. From here, the dough enters a warm, controlled environment for its final rise. 3. Final proofing. The dough comes alive. Proofing is one of the most critical stages in bread production. The shaped dough enters large proofing chambers, also called proofers. These chambers maintain exact temperature and humidity levels. Inside, yeast becomes active again. It produces more carbon dioxide. The dough expands. The internal structure becomes lighter and more delicate. This is the moment where bread gains its volume. Factories carefully control proofing time. Too short, and the bread won't rise enough. Too long, and the dough weakens and collapses. Sensors constantly monitor conditions. If humidity drops, steam is added. If temperature rises too high, cooling systems adjust automatically. By the end of proofing, the dough is soft, airy, and ready for heat. But one wrong move now could undo everything. 4. The oven, where transformation happens. From the proofing chamber, dough moves directly into industrial ovens. These ovens are massive, often stretching dozens of meters long. They operate continuously, with bread entering one end and exiting fully baked at the other. As the dough enters the oven, a phenomenon called oven spring occurs. The heat causes trapped gases to expand rapidly. The loaf rises one final time, reaching its maximum volume. At the same time, yeast activity stops. Starches gelatinize. Proteins set. Crust formation begins. Steam is often injected into the oven at the start of baking. This keeps the crust flexible, allowing maximum expansion before it hardens. Then comes the color. Sugars on the surface caramelize. Maillard reactions create rich browning. Aromas fill the air. This is the moment bread becomes unmistakably bread. 5. Baking zones and temperature control. Industrial ovens are divided into multiple temperature zones. The front zone promotes rapid rise. The middle zone fully cooks the interior. The final zone dries and sets the crust. Each zone is independently controlled. Different bread types require different baking profiles. Soft sandwich bread bakes differently than crusty artisan loaves. Buns require uniform color without hard crusts. Factories store these profiles digitally, allowing instant adjustments between products. This level of control ensures even baking, consistent texture, food safety compliance. By the time loaves exit the oven, they are fully baked, golden brown, and structurally stable. But they're still not ready for packaging. 6. Cooling, an often overlooked step. Fresh bread exits the oven extremely hot, often above 90 degrees Celsius. Packaging it immediately would cause condensation, leading to sogginess and mold. That's why cooling is essential. Loaves travel through long cooling conveyors, sometimes spiraling upward to save space. Air circulates evenly around each loaf. During cooling, steam escapes, internal moisture redistributes. Crumb structure stabilizes. This stage can take 30 minutes or more, depending on bread size. Skipping or rushing cooling would ruin texture and shelf life. Factories monitor airflow, temperature, and time carefully to ensure perfection. Only once the bread reaches the ideal temperature does it move forward. 7. Quality inspection. Before packaging, before slicing or packaging, bread undergoes inspection. Automated cameras check shape size. Color weight sensors ensure compliance with labeling regulations. Some factories also perform random manual inspections. Loaves may be sliced open to examine crumb structure. Anything that doesn't meet standards is removed. This guarantees that only top-quality bread reaches consumers. At this point, the bread is complete, but the process isn't over yet.